I am super excited to introduce to you the amazing Dr. Zoran Popovic. He is a computer science faculty member at University of Washington, founder of Enlearn, and director of the Center for Game Science. Zoran joined the computer science and engineering faculty a little while ago after completing his undergraduate degree with honors in computer science from Brown University, master's and PhD in computer science from Carnegie Mellon. His research positions have included Sun Microsystems Just System in Pittsburgh Research Center and at UC Berkeley. Zoran and his team at Enlearn are engaging in some exciting cutting-edge work I am hoping you will all really consider participating in and thinking about and leveraging AI in the classroom. So thank you again, Zoran, for joining us.
Plug in here quickly. Sure. That's not me. That's some other computer. That's me. Okay, thank you. Well, thank you for inviting me. I want to tell you about a number of things. The time is roughly 45 minutes. I'm going to try to keep it a little bit shorter because I would really like to hear your thoughts and reflections on what I will share. My main objective is to sort of try to convey what is really what is possible in this space, and to actually invite you to design for specifically for the needs of the students and what kind of experiences you see in individual situations. All right, so as a little bit of background, I do a lot of research at University of Washington. Some of that research actually ended up being relatively useful, so I decided to create a nonprofit that actually doesn't just publish papers, but actually deploys it at scale and tries to actually make an impact. That has now more or less dominated my work for the last 5 years, I would say. Just to give you some background of how I got there, have any of you heard of the game Folded? All right, some of you. So basically, it's a game that tries to solve a hard scientific problem in proteomics in biochemistry. If you know what the shape of these proteins is, you know the secret of life in some sense, right? So we started from people who knew nothing about this thing, and they actually ended up getting so good at this that they published not one, but now actually 5 different Nature papers. Discoveries that are published in the most eminent research publication venue. And for example, one of them was somebody contacted us about 15, maybe 2-3 years ago. They were working on this protein for 15 years. They couldn't figure out exactly what shape it is. We presented it to the players in the game. 2 weeks later, there was a proposal of a new protein. 2 weeks later, again, confirmed in the laboratory. So basically, we had 15 years, 2 weeks. This, of course, made big press, blah, blah, blah. Everybody's like, we have a completely new pathway to getting rapid expertise. Now, of course, it's a singular thing, so what... are you switching dynamically between? Okay. What happened is we applied this to neuroscience, and I just realized I'm actually wearing the same shirt as this thing. It's a little bit embarrassing. But when New York Times comes to take your picture, it says bring 3 shirts, and then they pick the one that you're gonna wear while they shoot you in the lab. It's pretty crazy. So they picked this one, and I picked this one. So what was interesting about neuroscience is we actually sped up the process at which neuroscientists reconstructed these neurons by 3.6 times by having completely new novices participate in this exciting endeavor. So that was interesting. We could actually accelerate this whole rapid expertise, which usually is like, 10 years to become an expert or 10,000 hours. Turns out that we kind of completely shook that whole concept at its core, because we showed that that actually doesn't hold water in many ways, and human potential can be tapped in different ways when you consider the whole person to really do exciting things. So the question is that I posed for myself is, okay, well, then I can just solve the K-12 problem too, right? And it turns out that's a very different problem, because instead of needing to get, even if you have a small tail on the Gaussian curve and you get those people to be good, that could still be 4 times more scientists that exist that work on that problem. It's a small X number. For an education, you have to take the whole Gaussian curve, move it all the way here, and squeeze it to be very near about 95% or more. And that, of course, is a completely different problem. But it turns out we were still able to sort of do some interesting things. So let me tell you what are the key top-level things that my research leverages that really makes me hopeful that some of these things are possible. First, instead of sort of just looking at the grading students when they finish their tests, we actually follow the students' thinking process as they're solving problems or they're trying new hypotheses, etc. And that kind of insight not only provides more information in less time, but it really is significantly more actionable than anything you would get on a standard assessment. Second, we're able to actually generate the curriculum on the fly. So for example, if we figure out that the student has this misconception, they're getting ready for their college level algebra class or calculus class, but they're missing something way back in 6th grade, proportional reasoning or something. We can actually pose a problem that specifically focus on exactly the misconception that they have. They practice it, and in 15 minutes later, that misconception is gone. If instead we were sending them to the chapter in some book in 6th grade, that would not only be demoralizing, but it would be like sort of this blunt instrument that would really not be effective towards actually achieving the goal. And the third thing, we're actually able to apply different machine learning methods that specifically focus in the situations where equity is an issue. And what I mean by that is that when you have standard algorithms try things, they do try different random things for 10,000 students, and eventually they become okay. In a real high-stakes environment where every second wasted for any student is not okay, that doesn't cut it, right? You can't just say, oh, don't worry, the algorithms will get better after the first 1 million students. Nobody's going to be interested in that. So how can the algorithm actually guarantee that every new student will gain benefit from the previous student that went through the platform in such a way that would specialize to a specific need that is highly varied, especially for the low-performing students? Okay, so with those 3 things, we started posing questions. We said, all right, let's see how we can teach people to solve these kinds of equations for X with full fluency, meaning knowing exactly what kind of strategy to take depending on whether X is in numerator, denominator, etc. And we posed this to the entire K-12 spectrum, including elementary school kids. We did it at the state level. We organized algebra challenges for all the teachers in K-12 to participate. We didn't do it just in Washington State. We actually did it in the whole country of Norway. We did it in Minnesota and why is that? Oh, it's cut off over there. Okay, good. And Uruguay. And that was very interesting because, of course, we can get hundreds of thousands of students. We actually really, for example, when Washington State participates, we actually analyze exactly who participated. Is it what is the reduced lunch ratios of people? And so we can actually really understand how we're actually affecting everybody. Are we just helping kids who are already predisposed to be helped by having technology, or are we actually able to help the key students that we're targeting? And here's some really surprising outcomes. Every classroom that participated in all of those trials across all of those countries and states that participated for an hour and a half or more, which is kind of what we asked. We asked teachers, during this week, just make sure the kids do something for at least an hour and a half on this problem. And we had, on average, 96% of all students reaching mastery, including elementary school. And when mastery is defined by solving the problems that I just showed you earlier, right? So that's kind of crazy, right? I mean, those kinds of problems are maybe even problematic for some people in community colleges, right? But we were able to actually do this across the board. Now, it's a very narrow skill. We didn't say, oh, well, let's cover the whole algebra, because that, of course, takes a little bit more than an hour and a half. But the key point is that this is possible. It's possible to start from scratch, because clearly the elementary school kids knew nothing about this thing, and they were able to reach that particular mastery. So that's what got me really, really excited. If you look at sort of what different kids need in order to achieve that mastery, you see that the gap is fairly large. Some students need up to 6 times more content, so they need to be engaged and try 6 times more things in order to achieve that mastery than others. So if you don't have a curriculum that can create just the right amount of extra practice for the specific students, there's no way you can get to that 96%. Okay? And that's what led me towards the research of highly precise personalization that will uniquely fit every student. All right. So through Enlearn, we're a nonprofit. We distributed this in many different places. We did math, we did reading comprehension, and we even have now more than 4 million kids using scientific inquiry games with PBS Kids. So PBS Kids, all of the new games are using our personalized things for all the young learners to learn through that. So let me just tell you what I mean by equity and really how we're driven by what we're trying to achieve. If you look at sort of these nominal curves, these are sort of, this is actually for NWEA. I don't know if any of you work with it. It's one of the assessment companies. This is how much students on average advance for every grade in terms of their mathematical knowledge, right? So this is kind of the average of progression of kids in the United States. And if you look at sort of how people measure progress, they look at kids who are below this curve, and they're saying, hey, they actually have the same velocities as other people, right? But they're still below the curve, right? So and the further these grades go, for example, in adult learning, this thing is significantly different as well. I'll show you soon. But really what we want to do is any kid at any grade should really be able, for that amount of time, to reach their full potential. And that full potential is not always below the curve, forever deemed to be in the purgatory, right? But it's really wherever they're actually capable of getting. So that's our goal, right? So if you really have an equity-focused approach to solving a problem, this is what you need to do. And so if we look at sort of at the college level, or maybe even people who've finished school and then they want to go back to college, which I'm sure a lot of your student population falls into that category. There's sort of a level of atrophy going on top of everything that I haven't gotten in high school, right? So it's kind of a downward going slope. And so there's actually even a greater opportunity to sort of not just bootstrap them from all the things that they missed while they were doing in high school, but also refresh that and remove all the issues that they've had, as well as make them remember stuff that they maybe used to know but they've forgotten, right? Okay, so that's our specific goal, and everything that we do in terms of design is specifically driven by this purpose. All right, so I will tell you the key things that through my research I have determined are really necessary to accomplish this. And some of these successes that I briefly outlined here all have these things in common. So first, what I found that it's really essential is to focus on the whole person. If you just look at how are you doing on the basic algebra that I need you to do before you can go on to college, that's not enough. Especially when somebody doesn't have low self-esteem, they think they suck at math. Everybody's been telling them that they're bad, for their whole life. That's a huge burden to carry, right? And everybody carries their different burdens. So the question is, if you don't account for that and have some way to actually address it, you will fail. Because if you're just reporting how they're doing in math, it's really, really hard to move the needle. Okay, so if you focus on a whole person, understand their mindset, understand how they can sort of be moved onto the path of productive struggle, and seeing the gradual improvement, and focus on gradual improvement rather than absolute location of where they are, and know that with any amount of time that they spend, they will continuously be better, everything changes. Okay, second, it's not enough to just have a computer-person kind of interaction. I wish that was, as a computer scientist, of course, I went there first, right? And then you see, that doesn't work. It's very, very limited effect. And the reason for that is that the professors, the teachers, the tutors, peers, they can all make a huge difference in this effect. And if you ignore that and just say technology will solve it, you're missing the biggest thing that can move the needle, right? So the question then becomes is not how can the technology just plug into the person's brain and fix it, but really how can technology understand the entire ecosystem and sort of help the teacher become give them superpowers in order to help the students, give them key salient information, figure out how peers together can help each other, etc. Okay. The third point is don't waste a second. What does that mean? What I mean by that is that we waste huge amount of time in high school, probably in college, in remediation classes. It's all too long and too ineffective, and it's just bringing everybody down. Teachers too, possibly. So the question is, how can everybody? Let's imagine a student. They're not quite sure how good they are. They're not even sure they should continue in college, right? They start something. In the first 15 minutes, if they see that they actually overcame something, that starts to okay, I can spend another 15 minutes and do extra thing because I am seeing the precise small movement of the needle, right? If that has to take a semester or even 2 weeks, it's super hard. Nobody can deal with that amount of delayed insight. It's especially if you're designing for the equity setting. So for us, don't waste a second means real-time adjustment such that a mother of 3 children who's taking a bus to get to the community college and has 15 minutes during that time to learn something knows that during that 15 minutes on her phone, she will remove 2 of her misconceptions. If you have that kind of perspective, you will actually want to do it. And things will change as a result. All right. Another one that probably is relevant to this group specifically is don't learn what you don't need, right? So if you want to go into nursing and you need to take statistics for it, but you can't take statistics because you're missing all this algebra stuff, there's only a specific part of algebra and other things that you need for statistics. And maybe even a specific things in statistics that you need to do the nursing, right? You don't need t-tests, probably even, right? That's like somehow the first thing that everybody goes in statistics. But the key thing is that how can we have scalpel precision in picking just the right things, going all the way from 5th grade that are required for the specific part of algebra that's required for the specific part of learning about normal distribution computations, right? And so if you have that kind of precise definition, it's not even, nothing is at the level of course. It's not even level of section or module. It's really at the level of a concept or a micro-concept. And if you can do it that way, you can see the process and you're learning, and everything that you're learning, it's immediately clear why you're learning it. Because you're seeing the direct need for exactly what you're doing. All right. And the final one is learn by doing. So we try to do, technology specifically, when technology wanted to revolutionize college education, what did it do? We said, we'll take lecturing and we'll put it on a bunch of videos, right? And what we know, lecturing in general by itself kind of doesn't work. The research, that's not the most effective way to have students learn, but instead, technology, what did it do? Take the known least effective thing and put it onto technology. It's terrible. I apologize. So the key thing that we were trying to do is say, all right, the best way we know how to learn, even when we're a baby, when the baby is like, taking that plate and dropping it down on the floor to see if it would break or not, it's learning from the experience. We always, that's how we're wired to do it. It doesn't matter how old we are, right? You learn by doing. So the question is, if you want to learn about how to factor quadratic equations, start by factoring quadratic equations and then have the system tell you exactly which pieces you're missing at that point in time. Don't go back to, some embarrassingly low grade to go over what fractions mean. That's glacial. It's completely ineffective, right? So the key question is, if you get it highly tangible, highly relevant, and learn everything on the fly, it's sort of like we're going into large-scale apprenticeship learning. We know apprenticeship learning works. That's how everything used to work before we had to get everything into scales and have it to have 30 students per teacher, right? Before that, we were doing a lot better. So the question is, can we somehow get some of that apprenticeship or on-task learning while we're still dealing with a number of students that we need to help? All right, so those are the key things. I don't know any platform or any approach that actually addresses any one of those. I wish I didn't have to address it because they're all super hard, but there is no free lunch. You really need to have these things if you really want to make a dent in the universe, and I kind of still think that that's possible. Okay, so let's take a look at college readiness. This is an example of some of the students, possibly students who want to enroll in your classes, who we give them a basic pretest. And this is a good example because, that carrot is super good. That they spend time drawing that carrot rather than, they're probably embarrassed by not being able to solve these problems as well, right? The carrot is saying math is hard. That's how they feel, right? That's exactly, it's a very good reflection of their thought process in that sense. But what if we can have students like that start with a pretest where they completely bombed it, they can't do anything. 20 minutes later, on the Enlearn platform, of course this is not anecdotal, there are 2 or 3 students that I can report this on, but 20 minutes later they're scoring 100 on that same test. Okay? That's the kind of thing that we want to move from anecdotal to everybody in your college classes. All right. Another thing I wanted to tell you is, with respect to, there's a whole bunch of exciting things that can be done about changing the perspective of students or mindset of students while they're solving these things rather than just mathematics. Let me just briefly go through this. My research shows that actually extrinsic motivation, like through badges and ranks and stuff, works only as a spike. So it's not well suited for education, because for education you need a prolonged interest and engagement in some level. This is good for marketing strategy if you want people to quickly buy, a particular toothpaste, but it doesn't really work for education. What if we could engage students on their agency, on their productive struggle, metacognitive skills, mindset change, or executive function improvement, right? So those are the kinds of things that we try to include. And the good news is we've done studies on 20,000 students and more. That mindset can be taught. It can be changed through simple feedback mechanisms on the right set of practices. So instead of rewarding problem solve or standard way in which we grade everybody, why don't we reward productive struggle? So for example, you try to solve a problem in our platform, you do it super well, super fast. The platform should tell you, oh, sorry, we didn't give you something for your mind to grow. No credit for this, let us try again with something that would actually be appropriate for your mind to grow. If you have that kind of thing, we call those brain points, very exciting things can happen. So in this case, this is in K-12, this study, so of course it's some fraction stuff on engaging game content, but we're able to actually assess, are they trying new hypotheses? Are they sort of giving up or trying a new thing from scratch? Are they able to subdivide a problem into smaller pieces before continuing on, etc.? So every one of those kind of strategic approaches
or indications of productive struggle is rewarded, not the fact that you solve the problem. And if you do that, here's an exciting thing to happen. At the end of this thing, after just 30 minutes of people being rewarded this way, we gave them a problem that we knew nobody would be able to solve. So super hard. And what we see is that kids who struggled the most on solving those problems persisted 30% more on this super hard problem just after 30 minutes of that treatment. So the treatment is so effective because it's fine-grained, right? At any time, this is sort of basic psychology. If you have frequent feedback on how well you're doing, you will change things. If your feedback is spread out a lot, you will not change as well. So this is really exciting to me because it shows the equity effect here, right? It's students who were not doing so well that were helped the most. And if you look at how the advanced students were helped, they actually didn't benefit that. In fact, it was kind of a little bit harmful for them. I was kind of happy about that. Because oftentimes, most of the technological things either help the most advanced students or lift all boats. And if you lift all boats, the ones that struggled the most were helped the least, because they were further behind. So you kind of didn't really make a difference in the equity setting at all. This is a completely opposite of that. So that's what's really exciting. All right. So then I said, okay, I've learned all this stuff. Now I'm ready to make a change. Unfortunately, if you look at the entire educational system, it's a complex system. There's so many things that factor in complex, puzzly ways. And if I were to just say, okay, I'm going to improve something about the student or something about the teacher or a curriculum, you can't ignore all these other pieces because they are relevant for student learning as well. So the question becomes, how can you have a systemic effect on the entire thing rather than just take one little control knob and tweak it like scientists usually like to do, right? Oftentimes we publish paper, hey, this knob is super cool. If you just crank it up, everything will work. It goes into the field, complete failure, right? And so we do it over and over again. There's the Department of Education has this clearinghouse of like what works in education, and it's the most depressing thing to see anywhere, right? Because kind of the conclusion is, we spend millions of dollars on every budgetary cycle, and what we come up with is nothing that actually makes an effect in the field. And this is why, most of the stuff that I'm trying to do is I don't try to do highfalutin academic research first. I go at scale. If at scale something makes a difference, then I'll publish a paper about it, right? And I'm actually go around educational circles trying to tell everybody else that they should kind of be doing that. Anyway, so I said, okay, so what can I do as a researcher? I have Enlearn is a small entity. There's maybe, 12, 15 people. My lab is another 12, 15 people at the University of Washington. What can we do, to make this enormously hard problem solved in such a way that I can actually see that I made a difference? Super hard. There's only one thing that after 15 years I figured out is maybe possible. And that is, if I provide rapid, effortless, continuous feedback to everybody in the system, not just students, but teachers, administrators, and that everybody will, with that frequent feedback, be compelled to improve. So from administrators, they can try, well, maybe we should do, let's say K-12, maybe we should do math right after recess because, kids will have more specific focus during that time. Or maybe we can have this allocation of teachers and their, with respect to how we rotate them for different aspects and different skills in the classroom. For teachers, maybe we should, instead of teaching this way, we could actually engage them with challenging problem first. All of these things are experiments. We don't want researchers to do those experiments. We want people in the field to make a difference for the specific cohort of students that they're directly engaged to address. And if you have, and you can't do that unless you can actually maybe even test things within every 15 minutes. So if you have a test that takes only 5 minutes and gives you full detailed information about what every one of your students knows and how much they moved it from what you did 15 minutes ago, you know what you just did. So you'll form your own opinion about what's good for those 15 minutes. The platform will also know, and will say, and if you did something really amazing and say, hey, tell us what you did, during those 15 minutes, because your students did super much better on this micro concept than anybody else in the platform, you share that information, all of a sudden that becomes available to all other teachers to potentially try that, right? So curriculum now becomes live, continuously improving by people in the field, as opposed to, coming from the academia, published through research. Somebody has to read that research, maybe create professional development, webinars that people go to, read about. They're not directly related to what they're teaching, so have to map it onto the classroom, and then try that on their students, and then wait for a year to see whether that particular intervention changed on some test that you have at the end. That's what we do now, right? And then we're wondering why that actually makes a difference. And then it turns out, I'm an engineer, computer scientist, and I know that all the complex system, the only way they can be improved is if you rapidly experiment and look at the feedback. There is no sitting in a chair in your faculty office and figuring it out. That just doesn't happen for complex systems. Education is one of the most complex systems. What we do instead, and this is, I'll credit John for this idea, it's effectively, education is kind of like we're flying a plane, right? Except that the pilot's blindfolded. We don't quite have any indicators, right? We have them at the end when we land, if we land, right? But before that, that's what we're doing, and it's kind of scary. I mean, that's why I picked this thing with jaggedy edges on all the mountains here, right? Because that's kind of what we're doing, and it's from the perspective of knowing how to solve really complex systems, this is unfathomable to me. So that's also exciting to me, because then say, oh, okay, I can change that. I can make a difference there. So it turns out if you look at all research done in educational psychology and education in general, and see what kind of strategies are most effective. So this is secondary aggregate research of everything. You find that one thing dominates all other things. I mean, this list is actually like several pages long. This is the top of the list. So the first thing is feedback. And this is the standard feedback. This is feedback of teacher occasionally stopping by your desk and telling you something, right? But what if we, like in our platform, you can increase that by 10x. 10 times more feedback will be 80 effect rather than 8 effect, right? So that was really exciting to me. I only found this out recently when, in fact, one of the potential funders pointed this out to me. It's like, great, I'll use this in all my talks. So the key thing is, and of course, metacognition and stuff, these are the things that I pointed out from the perspective of the whole person. So if we address these two things, and we scale them up by feedback 10 to 100 times more, we should be able to see a quantum leap in what is possible. All right, so let's just skip there. I want to show you sort of the key things in which how we're making a difference. So if we look at sort of the current classroom measures, the first thing that we find out is they're too late, right? So when do we do them? At the best, we do something at the end of the module, right? But it's at the end of the module. By the time the module is done, you don't have time to react on that, because you have to move to the next module. Your scope and sequence is a vicious and ruthless master, right? So you have to keep going. But usually it's the end of the year or at the end of the semester. So you kind of have to remember what you did then and maybe change something, right? So instead, what if we can just do it 2 and 3 times a day? I'll show you what that does to teachers when they have that kind of information. Also, they take too long. Everybody hates assessments for good reason. They're useless. They take too much of the time, and they're mandated by some higher power. All of those things are terrible, right? So, but what if you can do it just in 5 minutes? You'll know everything. All of a sudden that changes it. I'm not disrupting all the stuff that I want to do, and that 5 minutes may give me more information about what to do next than anything else I could possibly know by just running around the classroom, right? So, of course, when I get the end of the semester summary, it's just on these 4 big chunks, right? What specifically was the problem? And what is the dependency of the issues, right? So what if we actually had the precise thought process that kids are actually making mistakes on Because if you saw that, you can say, oh, I know what to do. I'm just going to spend 5 minutes explaining exactly this, derailment that 15 of my students have. The other aspect, of course, is focused only on the mastery, right? So what if we actually knew that this student needs a little bit more encouragement? They actually have, every time they find a problem where they're struggling on it, they run away from it, either by looking for assistance or help through the system, or they completely check out and don't do anything afterwards, right? If you knew that, and oftentimes teachers actually know that, but sometimes you don't know it in real time that it actually happens, you can jump in there and actually say, hey, have you tried this other way of doing it as you're doing that? And that changes things significantly. So let's take a look at some demos. All right, so this is kind of sped up, but every one of those little squares is an event of positive and negative thinking that the student has. I don't want you to necessarily, there's a lot of stuff in there, but the key thing I want to focus on in the stuff that appears there on the right. So there are basic insights about the classroom that the platform is presented to the teacher in real time that she can act on. She has full power to choose whatever she wants to do, but this information is available at her. So let's say the first one is basically says, The first one says, Katie had a breakthrough in scaling fractions. Give her a high five. Turns out research says that if you have actually physical contact with a student, the firing actuation in brain is 100 times higher than anything that technology can do. So instead of hugs, we said, all right, high fives, that's going to be a little bit more safe. This one is Aubrey needs concept help on a specific thing. So we automatically synthesized the work problem that's ideal for Aubrey to go through. And if the teacher clicks on this, the Aubrey will be invited to her to work through this specific highly curated problem that's specific for Aubrey in order to address. So it's teacher doing the work, but the kind of intervention she's helped by the exact intervention that's good. This one, for example, this is all three of these kids have exactly the same misconception. The platform suggests that they work on the problems together in a separate group rather than individually, because they have shown in the past to actually work well in a group, and they're close enough that group work will be sufficient. This one is slightly different. These three kids have the same issue, but the best thing to do is for them to all come to you and for you to work. So it's kind of a little mini lesson for exactly those kids on exactly the word problem that they're struggling with to solve, right? So you can see these are micro activities that are at teacher's disposal to choose to do. And of course, she can be suspicious initially, in K-12 especially, saying, well, I don't know, you're telling me all this stuff to do, right? But you try one of those things, and 5 minutes later, you see on a dashboard that things have moved. It changes your perspective. It changes your trust in the actual system in a very different way. You've made a difference. You feel like your superpowers have been added, and you're seeing the effect on a different kind of timescales. This is an interesting one. So Peter just had a realization, breakthrough. Maddie's on the cusp of it. So the platform says, hey, team them up together. Have Maddie drive, because she needs to learn, and Peter will be excited to share his discovery. So he will cement his knowledge by describing it to someone else, while at the same time Maddie would learn without taking the teacher resources because she's doing 10 other things at the same time. All right, so you can now you can see sort of these are the kind of personalizations for the teacher. You can imagine this is different content than college level content, but if you have let's say you have an Emporium model where you have a whole bunch of kids having many different issues. They're for 30 minutes, maybe you have them for 30 minutes. You could be using the same kind of system and actually helping as many of those kids, removing as many misconceptions for the group as possible. All right, so let's take a look. So what happens when a teacher has this kind of platform? We did this trial. Same teacher teaches multiple classes in middle school. Exactly same content, one paper, one with this platform. So green is paper, orange is the Enlearn platform. So what you see is that the teacher ended up giving 3 times more help units to students than the same teacher did without the platform. So it's as if you added 2 more highly effective TAs to the classroom just by having this information. Because the teacher, when she sees this highly detailed ways in which kids are, everything is actionable. So she can say, oh, I can do this. And so as a result, same amount of time, 3 times more effective. And probably empowered too, because you see the effect that you're making immediately, not 1 year later in the classroom. More interestingly, instead of helping the middle of the classroom, if you the bottom thing here, we actually order the kids based on how they perform. So you can kind of imagine teachers usually kind of teach to the middle, right? The advanced kids, they'll do well without my thing, and the other kids are kind of beyond my help, so my time is better. That's kind of, a sad truth of necessity of what teachers have to do. But with the platform, the same teacher does a completely different thing. She helps majority of kids that are struggling, because she sees them not as they're 3 grades behind, that's too hard. She sees them as exact concrete set of things that are missing. Each one of them is bite-sized, and I can help. All right, so that was really exciting to us. If you look at actually what students are doing themselves, the students actually end up doing 4.5 times more practice than the same students on paper. And what's interesting is if you look at this highly outlier group here, these are not advanced students that did 8 times more work than kids on the paper. These are mostly struggling kids who are doing just the right amount of remediations, and they're actually encouraged to say, hey, I'm churning, because if you have this kind of framework and you're behind, your velocity is naturally higher because you have more. Somebody who's highly advanced, they're going to struggle having the same velocity because they're already relatively high up. So it's kind of, the system is kind of naturally predisposed to highly incentivize students who have the most potential to improve. All right. And it's, not surprisingly, they're also doing better. You can also see that instead of having sort of the outliers that are doing badly, the entire population is squeezed towards the higher performing ones as a result. All right. So let's talk a little bit about college readiness. So as I've already alluded to, this is kind of the depiction of student knowledge, right? There's a whole bunch of holes, right? And that these holes could be everywhere. Oftentimes they could be even in middle school, not just high school, right? And so they come to you. You need to teach them new stuff, right? You can't deal with a Swiss cheese. You want like the flagship. What is that? The fully solid cheese. To start with. You don't want Emmentaler Swiss cheese. So what if you had a mechanism where since you know each one of the holes, you can actually address them relatively quickly. And what happens actually is you remove some of those holes, some other holes actually fill in very quickly because that was the key obstacle, right? You didn't understand the relationship between division and fraction, and they're the same thing. Once that falls into place, all these other things that you're struggling on, some kind of have a cascading effect as a result. So that's kind of what we're doing. So let's take a look at how things look on our platform. 5 minutes? All right. So everything looks like a paper, and you're not entering the final answer. You're actually highlighting things that you want to focus on, and you're doing an operation. Each one of those can show me misconception or correct or right way to do things, right? So instead of having only one answer to this problem, which is what every test is doing, I have 10 times more information from a single problem. This is how I can get way more information. In 5 minutes, I can know a huge amount of stuff. I can see whether they want to actually undo their work, so I can see are they exhibiting productive struggle behavior or are they just giving up. I can see later on whether they're checking their work. I can see what kind of actions they're picking. I see are they using the right academic language in the process, because every one of those actions that they're picking is a very specific thing. Here you can see they're reviewing their work, so I can see do they have the right practices of checking their work prior to submitting. All of those thinking processes are there for us to be able to see There are actually ways in which we map this to word problem solving, etc. But the key point that I want to show is, this is a little bit longer than I wanted to. All right, eventually they solve it. What I want to show you is what happens behind the scenes. So this is for exactly this amount of time that students solve. I think it's 90 seconds. We know exactly which misconceptions they could have exhibited, but they didn't. They did when they did the right thing, and these red things, which misconception they triggered along the way. I know exactly whether they use the right academic language or not. I know exactly, do they have a micro skill level of proficiency on a particular item there. And I have 17 thought events that I've captured during that one problem in just 90 seconds. So this is what allows us to make that test be super short and highly informative at the same time. The kind of information that we end up getting is, let's say, so in these 5 minutes, I can know that 15 students have issue with canceling terms on opposite sides. So I can say, oh, every one of these things is detailed enough that's actionable, right? And if I were to spend my time on something, what's the most valuable thing? Well, you just say, well, I'll pick the one where 15 students are struggling. There's also action groups. So for example, 11 students have shared set of misconceptions. So the best thing to do is maybe group them together, because you can work with them on exactly the same things, and they can have problems that maximally combine exactly what they need to work and no extra complexity on other things that they don't need, right? So each one of the groups has a automatically on the fly within those 90 minutes generated sub-curriculum that's unique for them. And with the idea is that every 15 minutes one of those holes in cheese better close. That's kind of the vision that we have. And there are other things I can tell you a little bit more, but we actually have insight on the executive function, so we can know how many of them give up when they're stuck. Do they try multiple steps at once, make a mistake, and therefore they should make more gradual mistakes? Are they able to identify multiple solutions to a problem, or are they always going to a very rote, robotic way of solving it one way, even though there are many other ways that are more efficient, etc. So all this information is available. And what I want to tell you is there are several different modalities in college level remediation that this kind of thing can be deployed with, and this is where I would really love to hear your feedback. First, personalized co-requisite. I don't know how many of you are actually considering co-requisite structure, but the idea is that rather than having one big remediation class, you're teaching smaller chunks that maybe take several weeks, and they're on particular things like proportional reasoning and linear systems. So one student could potentially be going through 4 of those, and they're smaller bite size. Now, of course, nowhere near the smaller bite size that's really necessary. You don't need proportional reasoning for 4 weeks to 2 months worth of time. But you could actually have highly focused measurements with respect to each one of those subparts. Here's another one. Let's say we have a college math course, and together we identify key checkpoints with respect to the material where some subparts of prerequisites are necessary, right? So for this first checkpoint here, we need to be able to compute with rational expressions, right? So variables in both numerator and denominator, right? So what you make sure that in parallel, as the course is going on, kids are working not on everything that they need, but the specific thing such that they're ready for this particular checkpoint. When you start that module, you want them to be highly primed for all the things that they need for that point in time. Similar thing for different later things that are required in the course. So this is happening in parallel, but it's in synchrony to exactly the course that you're taking. So there's no remediation, it's parallel, and it's highly curated for the specific course. If you have different types of courses, these things will obviously be different. Another opportunity, obviously, is course prep. Maybe they have a week before the course starts to just get on everything that they would really need ahead of time. And that's different for every different student, right? So we should really be able to get them primed, and to the point that when the teacher starts the class, she knows exactly how much they're ready on each one of those prerequisites, and then based on that maybe decide how much supplemental stuff is required, right? But a lot of stuff is happening slightly ahead of time. And if that's not enough, maybe you can insert some of those things during the weekends. Some weekends, some subsets of students would need some extra stuff to do, and then you insert those in there so that you don't block them on the college level class. Another one is, some of you may have connections to high schools or maybe summer programs right before, so an opportunity is to actually fill in the Swiss cheese during that time. And it's not, the idea is that this doesn't take months and weeks, it takes weeks or maybe even days for some people in this new structure. Another possibility is the Emporium model. So Emporium model, roughly speaking, every week, maybe two times a week, you have 30 minutes, which is extra in the afternoon or something, where you have one of your teachers help the collection of students that could benefit from it, right? But of course, all of them have highly disparate needs, right? So let's say one of those 30 minutes, you have some number of students. Each one of them need their specific thing. The platform gives you insight in the way that you've seen in real time, whether grouping of some students is beneficial, whether you can help some kids on proportions, some kids on factoring quadratics, etc. Right? So there's a way in which you can be highly multiplex in a very diverse classroom that has many different needs in this kind of Emporium model. So all of those things are possible, and in fact, the next, we're actually gearing up to doing a lot of these trials at the community college level, and I would like this to serve as an invitation to maybe design together. What are the best mechanisms, like some of these things that I described, that would maybe best fit the systems that you have, right? So the question is, no matter what it is, what we can offer is this rapid feedback and accurate diagnostics, where technology is not going to do all the work. It's going to give you that scalpel precision thing where your teachers will be 3 to 4 times more effective with the fixed amount of time that they have. And the students will see their immediate impact of benefits of that work within every 15 minutes, because that's how we design. Thank you.
Thank you so much. So we have about 2 minutes for a question or two. I suspect we have more than one in the room, but if folks have questions, Zoran's information will be available to you online and is posted on the website. And between he and John Mullen, his colleague at Enlearn, I'm certain that they will reach back out to you if you have questions. So in the interest of time, we're going to scooch along. So thank you again, Zoran. So how many of you in the room have taught before? How many of you have been faculty? Okay. So how many of you would have loved to have had rapid cycle feedback, regardless of discipline, in your classroom? Right? And how many of you would have liked to not only have had rapid cycle feedback, but have had a deeper understanding of the specific context within which your student was having gaps, and specifically your classroom? Yeah. Like, this is a pretty exciting mechanism of leveraging AI. Some of you have heard me talk about my angst about data analytics and the gap in ethics that continues to pervade that space, in my opinion. And so this is one of the most exciting evolutions, I think, that actually is targeting the equity work that we as a system really want to think about doing. So I would encourage you to think about how we might partner in co-designing some work with them around this space, specifically in math. Now, someone asked me yesterday, why math? And it's not just because I hated it in college, because I didn't actually. I really liked it in college. I know, sorry, Joyce Hammer. But it is because it is one of the single greatest levers for us moving our students into completion. If a student completes college-level math within the first year of entering the community college system, their likelihood of completing a meaningful credential is incredibly different than if they don't complete that college-level math in the first year. So, for those of us in the room, math matters for completion. So that's why math.